So now with the idea of zombie spiders, let's continue with math. We did what? Shape of a graph. So we're going to start looking at, or look at, the operations on functions. So consider two functions f and g. D sub f and d sub g are their respective domains. First operation we have is the sum. So the sum of f and g is a function. It's the function f plus g. It's found normally, f of x plus g of x. Domain of this new function is the intersection of the domains. Which makes sense. Difference of g from f is also a function. It's the function f minus g, found as f of x minus g of x. It has a domain, again, the intersection of the two domains. Product of f and g is also a function. It's the function f times g, found as f of x times g of x. Again, the domain, intersection of the two domains.
Excuse me, these PowerPoint, these also in Blackboard, right?
Not on Blackboard, on SharePoint.
Yeah.
They're not up right now, will be up.
Does the symbol there that comes in upside down mean?
That is intersection. It's just defined as what is in common between the two sets. Right, so think of a Venn diagram. It's the middle, it's where the two circles overlap. That's the definition of intersection. Okay. Then we also have the quotient, f over g. Found is just f of x divided by g of x. Domain is the intersection of the two domains minus any element that makes g of x 0. Right, so first you find, that should be a capital G, I'll fix that. First you find the intersection of the domains, then you look for any element in the domain of G that makes G 0 and remove it from your intersection. So those four operations, right, should look familiar. Those are arithmetic operations. We now have a new operation called the composition. So in composition, we use the output of one function as the input of a second function. For any input x and functions f and g, this action defines what we call a composite function written f open circle g, read as f composite g, right? And is defined as just f of g of x. Its domain. Set of every element in the domain of G that makes G of x in the domain of F. Given two functions, want to find the four combinations, sum, difference, product, quotient, along with their respective domains. Okay, so let's start by finding domain of F and domain of G. What is the domain of F?
Is it all real numbers or different two?
Close. There's another value that has to be excluded.
Zero. Or
How'd you determine 2 can't be in the domain?
Because I set the denominator equal to or not equal to 0.
You got x squared can't be 4, right?
Yeah.
What 2 values when squared give you 4?
Two and negative two.
And negative 2. It's a set of all real numbers except for positive and negative 2. What about the domain for G?
Everything but zero.
Everything except for 0. F plus G of x. It's just f of x plus g of x. What's the rule when you add fractions?
They need the same denominator.
Correct, they need the same denominator, but more specifically, what do you want to find?
LCM.
The least common denominator. Right? If you have denominators of 2 and 4, the LCM would be 4, not 8. Easiest way to do it generally is just to multiply your denominators together. In this case, the denominators don't have any common factors. So it will just be the product of the 2. Then the idea is what you do is you multiply each term by that least common denominator over the least common denominator. Or I'm sorry, not that way. You multiply each term, the numerator, just by the least common denominator. If you notice, you multiply that first numerator by the LCD, the x squared minus 4's cancel out. You're just multiplying the numerator by x in that case. Second term, you're just going to multiply the numerator by x squared minus 4 because your x's will wind up canceling. Simplify. X And like terms, 3x squared plus x minus 8 over x times x squared minus 4. I mean, conventionally, we don't expand out the denominator. You can if you want to. Then you just have x cubed minus 4x in the denominator. Right, so either one would be accepted in terms of the denominator. Domain. Intersection of the domain of F and the domain of G. Remember, intersection is everything that the two sets have in common. First domain has every real number except for plus minus 2. Second set has every real number except for 0. So what do the two sets have in common? Not everything.
All real numbers, but -2, 0, and 2.
Yeah, it's everything except for plus minus 2 and 0. Let's look at the difference. It's just f of x minus g of x. Technology is a wonderful thing. Well, rule for subtraction is the same, right? You have to find the LCD. Which means all of that work is going to be the same, except that plus there is a minus. Which means this becomes negative 2x squared plus 8. That becomes a plus. And now then just be negative x squared, right? X squared minus 2x squared. Domain is the same. It's just the intersection of the two domains. So that was simple. Just a few alterations. Product. just the product of the two functions, f of x times g of x. What's the rule when you multiply fractions?
The second number you have to flip it to the x over 2.
That's division. So with product, what do? That's if they're equal and you're trying to solve. But I think you start with multiplying fractions when you study fractions instead of adding, because it is just really simple. Multiply straight across. And then distribute. Again, that's not required to distribute the denominator. And we get 2x plus 2 over x cubed minus 4x. And the domain's the same. It's the intersection of the two domains. Let's move you back down for now. I may actually have to get rid of you. Quotient. F of x divided by g of x. And what was the rule when you divide fractions?
Yeah, they flip the second number.
Right. I've heard it keep, change, flip. It's the numerator times the reciprocal of the denominator. Now it's just a product of two fractions. X squared plus x over 2x squared minus 8. Domain. Is now going to be slightly different. What's going to happen if I try to do this? Yeah, of course you're going to do that. what we want now is go back to g of x. Where does g of x equal 0? So when does 2 over x equal 0?
My x is 0.
Well, if x is 0, then it's 2 over 0, which is undefined. So how would you solve an equation like that? It was mentioned before. I think you said it. Cross multiply.
There's only one there.
Isn't 0 the same as 0 over 1?
Yes. So multiply by 0 over 1.
You'd have x times 0, 2 times 1, you get 2 equals 0. The last time I checked, that is nonsense. That statement is what we call in logic a contradiction. It is always false. That means the assumption is incorrect. We assume that 2 over x equals 0. That assumption is wrong. 2 over x does not equal 0. Never equals 0.
Why would you say that equals
That's what we did when solving it. 2 over x equals 0. We were assuming that that statement was true
0?
when solving it. When you try to solve, that's what you do. You assume it's true when you're trying to find the values. But that led to a contradiction.
So what, you can't do it?
That means that assumption is wrong. So 2 over x does not equal 0. So there's no solution.
That just means x is 2.
It means x can be anything. Right? X, no matter what value you plug in for x, 2 over x will not be 0. Right? That's the math behind it. That means that this set here is empty. Has no elements in it.
Says g of x doesn't equal 0 either.
Correct, g of x can't be 0. What was g of x? G of x was 2 over x, wasn't it?
Yes.
So if g of x is 0, that means 2 over x is 0. Which we just said can't happen.
It's not.
Right, so that means g of x is never 0.
But you still put it in the domain.
Right, so what this set is saying, this one here, it's the set of all x in the domain of g such that g of x is 0. But there are no x's, right?
Can't be.
Right, which means it's empty. This set doesn't have anything in it. It's the empty set.
So we include that?
So that's what this here is.
Oh, that's all one. Okay.
Yes, this is all one equation, right? So this set is the empty set.
I see.
So if this question was like on the test and asked for the domain, you would just put the the empty set of brackets.
You wouldn't have to worry about writing all of this out that I'm doing.
Okay.
But I'm just doing this to illustrate how it's done.
Okay.
Because this isn't complete yet. This is an operation that we have to do now. So how this is read, right? This is set minus. So you look in here, look in your first set, and you take away everything in the second set. Oh, but the second set's empty, right? So there's nothing to take away. So this is just the original set. Right, similar to subtracting by 0. You're not subtracting anything. Yeah, the next question is going to have a case where that second set is not empty. So it'll be subtracting a non-empty set, and then we'll be able to see how it's done. Notice you find f over g, and you get this. Notice what happens if you just look at this function to try to determine the domain. You would just exclude plus and minus 2, right? You'd have 0 included, which is wrong. 0 can't be in the domain because it's not in the domain of G. Which means, yes, you do have to go through that whole process. Same question, 2 different functions. Again, let's start by finding the domains of f and g. Domain of f. We have a square root. That means what we're taking the square root of has to be non-negative, right? Greater than or equal to 0. So if 1 minus x is greater than or equal to 0, what does that mean about x?
Have to be at least 2.
So that's saying that. What's 1 minus 2?
1. Or negative 1.
Is negative 1 greater than 0?
No.
So that can't be it. Well, this is a linear inequality, right? Easiest way to solve it, add x to both sides. If you do that, you get this, don't you? 1 is greater than or equal to x. which is the same as x being less than or equal to 1. So that'd be our domain. Negative infinity to 1 closed. Domain of G. You know what? Let's keep that. Let's do it this way. X squared minus 4 has to be greater than or equal to 0. So x squared has to be greater than or equal to 4, right? Absolute value of x would have to be greater than or equal to 2. Another way of saying that x is less than or equal to negative 2, or x is greater than or equal to 2. No. F plus g of x just add the two functions together. Can that expression be simplified? So think back to your rules of algebra. So can we simplify that any further?
I don't think so. Well,
You cannot. Now, you're not allowed to distribute square root through addition. Right, so there is no simplification that we can do there. So just leave it in that form. I'm going to write the domain of f plus. I'm just going to write domain. Domain is the intersection. What do those two intervals have in common? And so this first interval is what? It's everything up to and including 1. The second interval, everything except for what's between -2 and +2 exclusive. Well, this doesn't contain 2 and larger, right? So immediately you know that's not in the intersection. But this doesn't include -2 to 1. So that would just be the intersection. Everything up to and including -2. F minus G, right? The addition just becomes subtraction. That expression again cannot be simplified. And your domain is exactly the same. I'm going to cheat again. F times G, product of them. Can that expression be simplified? If you take the product of square roots, can you simplify that?
Yeah.
You can. How? Right, so use numbers if you have to. What's root 2 times root 6? How do you simplify that?
Root 12.
It's root 12. What did you do?
6 times 2.
Product of square roots is the square root of the product. And when you FOIL it out, that's what you should get. Negative x cubed plus x squared plus 4x minus 4. And the domain's the same. I'm again going to cheat because I don't feel like rewriting everything. This I will have to get rid of, though. Quotient. Right, f over g, f divided by g are the same thing. I'm just going to write it this way so I don't have to rewrite everything. Can that be simplified? Take the quotient of square roots. So again, use numbers if you have to. Root 12 divided by root 6. Can we simplify that? What is it?
2.
2.
Oh wait, root 12 is that divided by root 6?
Root 12 divided by root 6.
I thought it was 2.
You're forgetting something.
Square root of the.
It's root 2. Again, what'd you do? Just divided 12 and 6, right? Quotient of square roots is the square root of the quotient. Now the question is, can that be simplified any further? And it cannot. 1 minus x, x squared minus 4 have nothing in common. Domain. No, I'm not going to cut you. I'm just going to move you out of the way for now. Move you down there. And is that intersection minus set of all x in our domain of G such that g of x equals 0. So look back at g of x. Square root of x squared minus 4. Where is that 0? How would you solve that? Square both sides first? X squared minus 4 equals 0. What are the values of x? And plus or minus 2, right? No, that's not what I wanted to move. That's what I wanted to move. Look in this interval. From this interval, we remove positive and negative 2. Is positive 2 in the interval?
No.
So you don't have to worry about removing it. Is negative 2 in the interval? You remove negative 2. Which means this now becomes open instead of closed. And there's your domain. So that's how set minus works. Now for the more interesting operation. Composition. Start with the domains of f and g. What's the domain of f?
Square root of x minus 6.
Well, that's f. What's its domain?
Minus 6, maybe.
Is it all real numbers but 6?
Why do you say that?
Because you have to set the you have to make it an inequality.
Right?
And you remove 6, which gives you x is greater than negative 6.
So why is it everything but 6? Because you did the math right. You said it wrong, though. This is what you got when you did the math. And you said everything but 6 would be all real numbers except for 6, which would include the negatives. All right, so greater than or equal to 6, 6 or larger. What about g? What's the domain for g?
They're just all real numbers.
It's everything, right? All reals. Now we want both compositions. We want f composite with g, which by definition, f of g of x. What is g of x? X squared plus 5x, right? So it becomes f of x squared plus 5x. How do you evaluate a function? Right? Look in the definition for f. Everywhere you see an x, put x squared plus 5x, right? Square root of x squared plus 5x minus 6. Right, that's it. You could factor that. It doesn't really serve a purpose. It doesn't really make it simpler. So let's just leave it like that. Domain. Here's the fun part. Definition of the domain. Set of all elements in the domain of G such that G of X is in the domain of F. Set of all real numbers such that x squared plus 5x is greater than or equal to 6. This is nice. This is the inequality we want to solve. I may do this on a separate slide. I think I will. Okay, what's going on? Oh no. Don't tell me my pen's broken. It is. You've got to be kidding. Will a new tip fix it? No. Okay, that's annoying. inside. Yes. Back up. I don't think it was. Okay, that's just annoying. Let me see if I can adjust the sensitivity. And let's see if that helps. No, it didn't. God damn it. If I rate this way, will this work? Please. No. Better anyway. Not really. I don't know what I'm gonna do. These pens are such garbage. What I can do is try and reset and see if that fixes it. I say should. I have to get a new pen. These pens are such garbage. What we're trying to do. Oh, right. Trying to solve that, right? want to move everything to one side. So we're trying to solve x squared plus 5x minus 6 greater than or equal to 0. And so the first thing we want breakpoints. Set it equal to 0 and solve. This can be factored, right? It's minus 1x plus 6. X is 1 or negative 6. Those are the two breakpoints. Remember, we now set up our test intervals. Negative infinity to negative 6. Negative 6 to 1. 1 to infinity. That should make it better. And so pick a value from minus infinity to minus 6, negative 10. That's negative, right? That's negative. Yeah. Negative times negative winds up being positive. Zeros in here. Negative times positive is negative. 5. Positive times positive is positive. Greater than means we take the positive intervals. The or equals means we include the endpoints. So there's our solution for this inequality. But remember, the whole point of that was because we were trying to solve for the domain. So set of all real numbers such that x is in this interval, which is just that interval, right? That would be the domain. Oh no, don't open the calculator. So annoying. Actually, I wasn't done, was I? That was just f of g. Now we have to do g of f. So I think what I'll do is do that. So there's my functions. G composite with f. Remember, that is g of f of x. F of x, square root of x minus 6. Look in the definition for g. Everywhere there's an x, replace it with root x minus 6. Happens when you take the square root and square it.
You get rid of the radical, so it's just x minus 6.
X minus 6 plus the square root, or 5 times the square root of x minus 6. There is something we could technically do. Again, I don't really see it as that beneficial. I could take this 5, square it, and put it in the square root. Right, that would then be the square root of 25x minus 150. That doesn't really benefit me in any way. So leave it that way. Domain. Set of everything in the domain of f such that f of x is in domain of g. So we want all x values. No, that's not right. It should be 6 to infinity, right? When all x values 6 or larger, such that the square root of x minus 6 is a real number. If you take any value 6 or larger, subtract 6 from it, and take its square root, isn't it a real number? So that would be the domain. For the sake of time, I'm going to go on to question 5, 6, and 7. Also because these are pretty important. Being able to do this is going to be important in calc. Given a composite function, you want to decompose it. Theoretically, there's an infinite number of ways to do it. Typically, we want the simplest way. So here's how I kind of look at it. We want to write this, right, to be f of g of x. Outer function is f, inner function is g. Well, look at the whole. Isn't that a function raised to a fourth power? And what's being raised to the fourth power? So that would be my decomposition. F of x is x to the fourth. G of x is 5x minus 3. Right? Same process now on the square root of 1 minus x squared. Again, the goal, write this as f of g. As a whole, the outer function, we're taking a square root of something. So let's say f of x is root x. And then what are we taking the square root of? That would be our g of x. Okay, so here, 1 over the quantity x squared minus 5x plus 6 to the 2/3 power. As a whole, if I look at this function, 1 over a function being raised to the 2/3 with g of x then being x squared minus 5x plus 6.
What utility does this have? Like, I assume this is useful for something else. Is this step to something else?
Chain rule. In calculus 1, you use it in the chain rule. For decomposing functions. In terms of function composition, it does have a lot of applications. If you have something that is a function of some other quantity, that would be a composition of functions. Any questions on the function operations? And some trivia. It's like math, Jeopardy kind of information. We looked at arithmetic functions, right? Sum, difference, multiplication, division. How many arithmetic operations are there?
How many what, sorry?
Arithmetic operations. And so how many operations do they teach you in primary school?
6.
6? What are they?
I'm thinking of something else. Or I'm thinking of PEMDAS, but it's not I remember from high
That's
school.
order of operations.
Oh. I thought that was the same day.
What is it? So how many of them? All right, so you're taught that there are 4 operations. That's a lie. There's 2. There's addition and there's multiplication. That's it. Subtraction is defined as addition of the additive inverse. 1 minus 2 is defined as 1 plus negative 2. Subtraction itself is thus not actually an operation. Division is defined as multiplication of the reciprocal. And so 1 over 2, 1 divided by 2 is actually 1 times a half. Which is why in PEMDAS, multiplication, division done at the same time. Addition, subtraction done at the same time. Because division is multiplication. Subtraction is addition. So you were lied to for most of your life, which is always a lovely thing. Now, 2 comments. First, you should have noticed there's no camera up today. Someone bumped into it on Wednesday, knocked it over, and broke my screen. So I'm getting it replaced. I had insurance on it, so it's all fine. It's just going to be a couple weeks. So it'll be screen recordings instead of the actual recording. So screen captures instead. Second, this was not a comment I wanted to make. Yes. I do have another pen at home. It's not this, excuse my language, shitty slim pen 2. These things are such garbage. It's already my second one. It's the original pen that came with the Surface 7. It's better. I just have to find it. I know it's at home in my desk somewhere. I just have to find it. I will then figure out how to do these slides. I'll either write on the slides and then upload them, or I may just capture what's on my pad here and post those pictures on the slides. But again, that's going to require me to do it at home. Either way. So it's going to take me some time to get these slides worked out. Hoping I can definitely find that pen so that I can go back to writing on the slides on Wednesday. And I have to do this doc cam. I'm so glad I carry this with me. Otherwise, we would have been in a lot of trouble.
You want to go back to the old school and the whiteboard?
Can't record that, can I? I don't even have the markers.
I don't want to see that.
So.
Easier on there.
You had a homework due today before class. Second homework will be due Wednesday. Third homework due next week. Project is also due next week, so you're running out of time on that. So continue working on that. See you Wednesday.